Welcome students, this is actually a response video because the original author has made a question like this and posed why 99% of the people of the students or so find this hard. Okay, and then uses the concept of LCD. Well, I can give you the solution, or in other words, I can give you the answer. Why 99% of the students find this hard? You know why? Because while explaining this concept, either by the teacher or by the tutor, they use this terminology, what is called as LCD, to solve this question. That is what makes the listener, in other words, that is what makes this entire concept too hard for students, because they use this LCD. So people start to look for least common divisor. So that word least actually misleads everybody, in all honesty. Either they might use LCD or LCM, all because you have a fractional quantity like this and you go and tell the students to go and use LCD and evaluate this. We don't need to use any least common divisor. All we need to do is to just use CD, common divisor. Now for a question like this, foremost you have to make an observation. What is the observation? Can you reduce this? Can you reduce this? This is the first thing that should come into your mind. Only after getting an answer for this particular question, can you reduce these fractions? Only then you should move on. Now clearly you can see here 3 over 40 you cannot reduce it, so I'm retaining it as it is. Now 5 over 85, clearly I can reduce this. 5 divides 5 once and 5 divides 8 once, and then I carry 3, then 5 divides the quantity 35 17 times. So now I need to evaluate this. How do you do it? All you need to do is take this quantity 40 and take this quantity 17 and place it, and next pose a question. How many times can this number divide this number? You are posing this question. How many times will this number be divided by the denominator or by this quantity 40? Straightforward, 17 times, and then you place 17. So all you need to do is multiply 3 with 17. 3 times 7, 7 3s are 21, 2, 3 1s are 3, 4, 5, 51, positive. Now find out how many times this number can be divided by 17. Clearly 17 gets cancels, you got a 40. Just place 40 there. Now multiply 1 with 40. What do you get? Place that. What do you need to do? Add 40 with 51. 1 and 9. Place it. 91. Now you got a 40 and a 17. Now what you got to do? Multiply 40 by 17. Or the other way, multiply 17 by 40. Because this would be a far more better way. Why? Because I got a 0. I don't have to worry about it. Just place a 0. 7 4s are 28, 2, 4 1s are 4, 5, 6. 6, 8, 0. That's all. This is the solution for this question. Now, instead of doing all these things, you know what people have been taught? You have a 3 and you have a 40. You have a 5 and you have a 85. And then they say, use the concept what is called as bowtie. Okay? Bowtie method. So what do you mean by bowtie method? You multiply this with this. Right, place that 3 times 85, and then you place this positive sign, and then you go and multiply this with this. Okay, something like that. Okay, this itself, it's confusing. I am getting confused, right? Right, so you go multiply this with this, place a positive sign, and then multiply this with this, place a positive sign, and then multiply this with this and place it. I'm not sure if we are going to get the answer or not. I don't know. You follow me. Now the problem is, they say that the bow looks, in other words, the bow tie method is this, right? In fact, the bow tie looks like this. Now I have a big concern. The concern is, say, take for example, you take 3 over 5 and you got 1 over 3. Now according to this diagram, now you saying that you are going to be using the bow tie method. Now when I say you, I think the people who are adopting this bow tie method to solve this. Now what they're saying, you cross multiply this with this. Okay, so I get a 9. Then they're saying you cross multiply this with this. Okay, alright. And then you multiply this with this. And then, so that's going to be 15. My point is, if you were to be following this, or if you say that you are following bow tie method, is not the bow tie as to be followed in this fashion? you say 3 over 5 and you want to calculate this, if you are going to be adopting this pattern, is it not like this, like go over here, multiply this and this, and then follow it up by multiplying this and this, then multiply this and this, and then multiply this and this, right? So what do you got to do? You got to multiply 3 with 3, and then follow it up by multiplying 3 with 5, and then follow it up by multiplying 5 with 1, then follow it up with multiplying 1 with 3. So according to you, this should be the output. So what do we get? 3 3s are 9, 3 5s are 15, 5 times 1 is 5, and 3 times 1 is 3. So 9 and 3, you get 12. This one is going to be 20. So this is going to be 32. So this should be your answer. No, but this is absolute. If you are going to be claiming this to be the LCM or LCD, this is absolutely wrong. I shouldn't use even an asterisk. This is the way I say wrong, right? So the point what I wish to say is, whenever you are introducing concepts like, okay, follow up the bowtie method, and then they also use the concept of cross multiplying. There is a huge mistake when you use concept like cross multiply. We don't use actually concept like this, cross multiplying, for quantities like this, because that introduction of these things is actually throwing off, in other words, confusing the student, confusing. No matter what number is given, all you need to do is too simple. What you got to do? Say, for example, you got 7 over 9, and you got, say, 10 over 21, something of this quantity. Clearly, these numbers are not reducible. Okay, so in this case, I need to find a solution. I need to solve them. All you need to do is draw the line, place 9, place 21. Now, what you got to do? You will have to find out how many, let me use the space, how many times 9 times 21 can be divided by this quantity 9. Simple. Cancel 9. What is remaining? 21. Just place 21 there. Maybe you can place a product sign. Or you don't have to place a product sign. Place the number within parentheses. Now multiply 7 with 21. 7 ones are 7. 7 times 2 is 14. Simple. Now find out how many times the same number, 9 and 21, can be divided by 21. I know 21 can be cancelled, and all that remains is 9. 9 times 10 is 90. Now what should I do? All I need to do is add. That's it. 7, 0, 7, 4, 13, 1, 2. So what do I get? 2, 3, 7. Now what should I do? Multiply this quantity. 9 with 21. 9 times 1 is 9. 9 times 2 is 18. That's it. This is the solution. Simple. Now you might be wondering, or you might be asking, when do I use the concept of LCM or the concept of LCD? When do I use? You don't have to confuse yourself by the terminology LCM or I should say the terminology LCD or LCM. You don't have to get yourself lost at all. So I think I have answered this question. Why 99% of the students are finding it hard? Because the teacher or the tutor or the person who is instructing is bringing in concepts which are not connected, or I should say jargons which aren't connected to the mathematical topology that is going on between the lines or going on behind the scene. Now before I could complete, let me just give you a small illustration. When do LCM come into play? Okay, now if they ask you find the LCM of numbers like 24, 36 and 40, if they ask you to find the LCM, okay, least common multiple or least common divisor, name it whatever you want. So if this is a question that is given, there is no numerator at all. This is straightforward. First observation that you have to do. Now I'm just showing you this because since I have brought you all the way to this question, at least you know some techniques or some methods to take back. Now this is the quantity that is given. You are asked to find this out. Now draw a line like this. This is the best way to go through this question. Draw a line like this, and then find out what can divide all these numbers when you start off with. Okay, can 2 divide? Yes, 2 divides all of these. Okay, so 2 divides how many times? So 12 times. 2 divides how many times this particular quantity? 2 divides 1 and 2 divides 18. And 2 divides how many times this particular quantity? 20. And then 2 can again divide. So you draw a line like this. So 2 divides 6 times, 2 divides 9 times, 2 divides 10 times. Now can 2 divide? Yes, 2 can still divide. Of course, there is a quantity called 9. 2 cannot divide, but don't worry. All you need to do is just bring the 9 down. Place the 2. 2 divides 6, how many times? 3 times. Can 2 divide 9? No. Bring the number now. Just bring the number down. Can 2 divide 10? Yes. Place it. Now, can 2 divide any of these numbers? No. So, what are you left with? You got a 3 and a 9. Of course, I got a 3 which can divide. So, come out. Can 3 divide 3? Yes. Can 3 divide 9? Yes, 3 times. Can 3 divide 5? No. That's it. I've got 1, 3, 5. Is there any other number that can divide all these 3? No. Is there any other number that can divide at least 2 of these numbers? No. Is there any other number that can divide at least 1 of these numbers? Yes. What is that? 3. 3 cannot divide 1, so bring it down. 3 can divide 3. So, how many times? 1 time. Can 3 divide 5? No. Of course, 3 divides 5, but there is a remainder. But we are looking for quantities where the remainder is 0. Because some of you might say, wow, well, you're saying 3 doesn't divide 5. Of course, it divides 5, but I'm looking for the mod remainder being 0. So, 3 does not divide 5 from that perspective. So, bring that number down. Now, out of all these numbers, what do you think would be the number that can divide 5? Naturally, 5. So, place the number. Can 5 divide 1? No. Bring the number down. Can 5 divide 1? No. Bring the number down. Can 5 divide 5? Yeah. So, what have you got? You got 1, 1, 1. So, most of the times, you have to make sure that you are reaching this point. This is your point. Okay, this is your point. Of course, some of you might stop here. It doesn't matter as long as you know the LCM. So if I were to write down the LCM, what should I do? After you have reached this stage, this is your LCM. Okay, so how do you write it? Go over here. Okay, place the number 2. How many 2's are there? 1, 2, 3. So place it there. Place the product sign. 3. How many 3's are there? 1, 2. Place it and place it 2 there. How many 5's are there? There's only 1 5. So just place there 5. Now 2 power 3 is what? 8. 3 power 2 is what? 9. 5 power 1 is what? 5. 8 times 9 is what? 72. That has to be multiplied by 5. 5 times 2 is what? 10. 7 5s are 35, and that is going to be 360. This is called as the least common multiple. If they ask you a question, find the least common multiple. This is how you have to answer. Thank you, students. I hope you understood today's class. Have a nice day.